Designing an object is always a process of coming up with a proposal, testing, and iterating with improvements. When it comes to wing design, it is all about preventing bending and torsion, which is strictly related to second moment of area and polar moment of area. The entire design process starts with calculations and predictions. Most of these are done on an Excel spreadsheet. Since both second moment of area and polar moment of area are based on the dimensions of the cross-section and the aspect ratio is given, we're basically making adjustments to the height and width of the cross-section, as well as the internal supporting structure. Calculations will give us a solid understanding of the dimensions we're going forward with. We then make an illustration via drawing as a clarification while building. A CAD model is also built in SolidWorks to show how the real wing will look like in 3D. Next up is the building and testing process. On a real aircraft, it is the beam in the wing structure that takes almost all forces, and this is the reason why we're only building and testing beam simulators. Before putting on real weight, we proof tested the beam to see if it is properly built to prevent any failure due to build qualities. The real test is conducted with the 2 kg MACE simulator sitting on top of the beam, causing it to bend. Our first proposal failed due to a higher than allowed deflection angle. This is expected since our calculations shows that this design just passed barely and any build quality issues will result in a test failure. But we believe that if we're not failing, we're not innovating enough. And since we're going back to the drawing board to redesign the structure for the next round of testing, starting with calculations again. Since deflection is equal to the second derivative of the tip bending moment over the foam board's Young's modulus, which is a fixed value, times the second moment of area of the cross-section, a decrease in deflection could only be solved with an increase in the second moment of area. With the new design, new hand and computer illustrations are made. Building and testing resumes for this new design, and the design passed the deflection test. And now, onto the torsion test, which is also passed. However, there is a slight error between the calculations and the real testing. While calculating, the beam is expected to be stick directly onto a wall. However, this became extremely difficult when testing our beams. A lot of failures occurred when the glue between the beam and the wall failed before the beam deflected. As a solution, we decided to test it by hanging it along the desk. However, it is clear that the hanger itself can provide some squeezing and prevent some torsion, and that makes testing somewhat different than the prediction. This will be improved for future designs. To wrap up, designing is always about core calculations and iterations. Always understand the core calculations and focus on the requirements and iterate with testing. This is how engineering design should work. Thanks for watching.